Hello there, and welcome to another video on GCSE Computer Science Theory. This video is going to be on the topics of ASCII and UNICODE. But before we get started, let me introduce you to the topic of character encoding. So character encoding is the process of assigning some kind of binary representation to characters on a computer. And when I say characters on a computer, I don't mean things like Mickey Mouse or Donald Duck or what have you. I mean things like C or F or the percentage sign, pretty much anything you can type in on your keyboard. So, letters and numbers and symbols that you can display on your screen or type in using your keyboard. Why is this even an important subject in computer science? Well, let me explain through the magic of Notepad. So, let's go back to a time before there was an established method of encoding characters. So let's go back way into 1959, before character encoding was a thing standardized. Computer 1 would say hello in binary, and by the way, this is something called binary encoded ASCII. Computer 2 isn't familiar with that language at all. I mean, Computer 2 speaks binary, but Computer 2 is not familiar with this type of coding. So Computer 2 is like, what? I don't even, so you get the idea. We need to make sure that all computers across the world are following the same character encoding method. Fortunately today, because, about 50, 60 years has passed since the 60s and 70s, all computers are able to understand a format called ASCII, which is what we're using today. It's the formatting I'm using for this notepad. It's the formatting that my presentation is using. It's using something called ASCII. So, what does ASCII support? ASCII supports uppercase A to Z, lowercase a to Z, so it's important to distinguish that these are different characters, and 0 through to 9. Again, important to distinguish that these are not integer values. These are actually the symbols 0 to 9 that you would find on your keyboard. ASCII also supports a bunch of punctuation, and it also includes things like the space key and the return key, or the enter key, as you young people might call it, on your computer. So pretty much anything on your keyboard has some kind of ASCII value behind it. ASCII takes up 8-bit per character. That means there is a potential for 256 different symbols we can store inside of ASCII encoding. Some other things you need to be aware of when it comes to ASCII. ASCII can be considered as 7 or 8 bits. So if you told the examiners it was 7 bits or 8 bits, you'd be correct in both instances. The reason why there's some ambiguity is because the 8th bit can be used for storing extra symbols, or it can be used for error checking purposes, but you don't really need to know about these things in that much detail. Another thing you should be aware of is that ASCII is logically grouped together. What does that actually mean? Well, let's take uppercase A for example. The decimal encoded ASCII for uppercase A is 97. Uppercase B is 98. And you can imagine that uppercase C is going to be 99. The same goes for lowercase. Lowercase a is 65, B is 66, and lowercase c is going to be 67. It seems like a peculiar place to start, 97, but if we look at the binary encoding for this, if we ignore those first 3 bits, we can see that we just have the number 1 in binary. So this means 1, A is the first letter of the alphabet, so it makes sense in that respect. For lowercase a, we have the same thing. If we ignore the first 3 digits, we have 1 left over, and 1 is the first letter of the alphabet. So a more modern alternative to ASCII is UNICODE. UNICODE is good because it supports everything that ASCII does. In addition to doing everything that ASCII does, it supports scientific symbols and foreign alphabets such as Arabic, Russian characters, and Japanese characters. It also supports emojis, or emoticons, if we were to be technical about it. Unfortunately, because of all these extra characters and symbols that we have in this encoding system, UNICODE requires 16 bits per character instead of 8 bits. The reason why I've put that in asterisks is because there are also 32-bit variants of UNICODE available. So just comparing these two encoding methods at a glance, ASCII is arguably better because it uses less space. Unicode is arguably better because it supports scientific symbols and characters. However, ASCII is arguably worse because it is limited to Western characters. Unicode is arguably worse because it takes up more space per character. Now carry on watching if you would like to see an example of ASCII versus Unicode in practice. So on my screen I've got an example of an ebook, and everything in this book is ASCII symbols. There are no special characters or foreign characters on the screen. It's just 100% pure ASCII. And as such, I've saved it in an ASCII format, and it only takes up 74 kilobytes. However, if I were to edit this document, save it using Unicode, and I'm just going to rename it so I don't delete the original. So if I save this using Unicode encoding, we can see the file size has doubled. And we haven't got any extra symbols or characters or anything like that. Everything has stayed exactly the same, but the file size has doubled. Let me explain why that's the case. Because in ASCII, there are 8 bits reserved for each character. Unicode, it's 100% compatible with ASCII, but it requires 16 bits per character. So as a result, we have to pad every single character with 8 zeros.